Hello viewers, how are you? How have you been? Hope you've been good. Yet again is Access Point Academy video lecture series. Yeah, a quick one. In our video series today, we want to unravel the concept that has to do with Redox Chemistry. Okay, Redox is actually the acronym, for reduction and oxidation. So meaning redox means reduction and oxidation. All right. So in this lesson, we shall be looking at redox reactions, that is reactions of reduction and oxidation. Okay. So now we look at different views, different definitions of redox reaction. Now there are different definitions for reduction and also oxidation. So we're going to look at different views of redox definition for reduction. Now one of the view is that redox in terms of addition or removal of oxygen and hydrogen. All right, so we're going to look at the definition of reduction in terms of addition or removal of oxygen, and also oxidation in terms of removal or oxidation or addition of oxygen. Then another definition for reduction and oxidation, which we're going to look at, is redox in terms of addition or removal of electropositive element or electronegative element. So we're going to look at that definition too, another view for redox reaction. Then we're going to look at, we will define reduction also and oxidation in terms of electron transfer. Okay, in terms of electron transfer. So we're going to define oxidation in terms of electron transfer, reduction in terms of electron transfer. Then finally, we're going to look at the definition of reduction and oxidation in terms of oxidation number. So now sit back, relax, and enjoy your lesson. Now the first one is redox in terms of addition and removal of hydrogen or oxygen. So redox in terms of removal of or addition of oxygen. Now, how do we define reduction? How do we define reduction in terms of hydrogen and oxygen? Now, we can simply say that reduction can be defined as the addition of hydrogen, as the addition of hydrogen and removal of oxygen from a substance. So redox, meaning reduction, is defined as the addition of hydrogen and removal of oxygen from a substance. All right, so that is reduction. Reduction involves the addition of hydrogen and then the removal of oxygen from a substance. That is reduction. However, for oxidation, the case is different. Now we can define oxidation as the addition of oxygen. So the reactions that involve the addition of oxygen is oxidation. So oxidation is defined as the addition of oxygen to a substance and removal of hydrogen, all right, and removal of hydrogen from a substance. So now oxidation has to do with addition of oxygen and removal of hydrogen. Now let's look at this example. Look at this equation. The reaction of zinc with water to yield zinc oxide and hydrogen gas. the reaction of zinc with water to yield zinc oxide and hydrogen gas. Now, one of which is oxidation and reduction. So reduction and oxidation will occur here simultaneously. All right. Now, zinc here, when it's reacted to yield zinc oxide, oxygen has been added to zinc and it forms zinc oxide. Now, what happened there is oxidation, because we said oxidation is the addition of oxygen, okay, to a substance. We have added oxygen here to zinc, okay, and has become zinc oxide at the product side. So that is oxidation. Now, then here we have water. Oxygen has been removed from water to yield hydrogen, okay. So oxygen has been removed from water to yield hydrogen. So the removal of oxygen is known as reduction. So removal of oxygen is reduction. All right. So now from here we can say that zinc is oxidized to zinc oxide. Zinc is oxidized to what? To zinc oxide. All right. And that water, H2O, is reduced to hydrogen. Okay. Water is reduced to hydrogen. Do you get that? So now that is an illustration. Zinc here, oxygen has been added to it. So at the product side, you have zinc oxide. So addition of oxygen is oxidation. Then water here will remove oxygen from it. So that is reduction. It forms hydrogen gas. So that is reduction. Now, in the next illustration, we have another example that involves the reaction of copper oxide, that is copper 2 oxide, reacting with sodium. So now this will yield sodium oxide and copper. All right. Here, sodium, we added oxygen to it to form sodium oxide. So sodium has eventually formed sodium oxide. And the addition of oxygen to a substance, we said, is oxidation. Okay. Now this is zinc, this is copper 2 oxide. It has oxygen in it. Okay. Now, at the product side, there is no more oxygen there. So which means oxygen has been removed from copper oxide. So now this is reduction. Okay. So now we can simply say that sodium is oxidized to sodium oxide and copper 2 oxide is reduced to what? To copper. So now that is the definition of oxidation and reduction in terms of addition and removal of oxygen and hydrogen. Now, another definition of reduction and oxidation is in terms of addition or removal of electronegative or electropositive elements. Okay, that is another method, another way of defining redox reaction. Now, but meanwhile, we must understand the meaning of electropositive element, and also we must understand the meaning of electronegative element. So now, what is an electropositive element? Now, electropositive elements are elements that have the tendency, okay, they are the elements that have the tendency to donate electron or electrons, okay, and forms positive charge cations. They form positive charge cations. So those elements that have the tendency, okay, to donate electrons and form positive charge cations, we say they are electropositive element. So example of such element is potassium. We have sodium, we got calcium, and many more. So these elements can actually donate electrons. Now look at sodium. for instance, has atomic number of 11. Okay, so now when you draw the electronic shell, electronic configuration, which is 281. So now, meaning sodium can donate, can give out the outer one electron, this outermost electron, and on giving it out, it's going to become Na plus, which is now 28, losing an electron. Okay, so now, which means sodium is an electropositive element. Sodium is an electropositive element. It has formed positively charged ion because it loses one electron. Okay, so those elements that can donate electron to form positively charged element, so they are known as a electropositive element. So now, the next definition, we have to understand the meaning of electronegative element as well. So electronegative elements are those elements that have the tendency, okay, they have the tendency to attract electrons to form negative charge anions. So they have the tendency, okay, to attract electron. So they attract electron to form, negative charge anion. So example include fluorine is an example of electronegative element. Then chlorine is also an example. Oxygen is also an example. Now, these substances, these elements, will gain electron to form positive charge. Now, let's look, for instance, fluorine. Fluorine, for instance, has an atomic number of 9. An electron configuration is 27. Now, for it to attain the octet configuration law, it needs one electron, okay? So it's going to attract an electron toward itself, and it forms F minus, which is now 28. So it has formed a negative charge, okay? So it is the most electronegative element, fluorine. So it has a tendency to attract electron toward itself, all right? So now, we now give the definition of reduction in terms of electropositive and in terms of electronegative. So we can now define reduction. Okay, reduction is the addition of an electropositive element to a substance and removal of electronegative element from a what? From a substance. Okay, so that is reduction. Addition of electropositive element to a substance and removal of an electronegative element from a substance. That is reduction. However, oxidation is the addition of electronegative element to a substance and removal of electropositive element from a substance, and that is oxidation. So oxidation is the addition of electronegative element to a substance and removal of electropositive element from a substance. Okay, so you know the definition of electropositive element and electronegative element. So, and you know the meaning of reduction and oxidation in terms of electropositive and electronegative element. I repeat, reduction is the addition of an electropositive element to a substance and removal of an electronegative element from a substance, while oxidation is the addition of electronegative element to a substance and removal of electropositive element from a substance. All right, now let's look at this illustration to buttress our definition for oxidation and reduction in terms of addition or removal of electronegative element. Now, in this reaction, we have zinc reacting with hydrochloric acid to yield zinc chloride and hydrogen. Now, here we added electronegative elements to zinc and it formed zinc chloride. Okay, so zinc has been transformed from zinc to zinc chloride. Do not forget that chlorine is an electronegative element. So now addition of electronegative element to zinc makes the process oxidation. All right, makes the process oxidation. Then here, hydrochloric acid has actually formed hydrogen gas. Now, what happened to hydrochloric acid? For it to form hydrogen, chlorine has been removed from hydrochloric acid. So now, removal of and don't forget that chlorine is an example of electronegative element. Okay, so now the removal of electronegative element, okay, that is what? Reduction. So now, which means that zinc is oxidized to zinc chloride and hydrochloric acid, HCl, is reduced to hydrogen. Now, another strategic and analytical example, okay, is the reaction of hydrogen sulfide with chlorine gas to produce hydrochloric acid and sulfur. Now, sulfur is an example of electronegative elements. Okay, hydrogen is electropositive. Now here, hydrogen sulfide has been, we have actually removed hydrogen from hydrogen sulfide and it forms sulfur. Okay, so now hydrogen has been removed from from hydrogen sulfide to form sulfur, which makes this reaction, okay, an oxidation. Don't forget, we said oxidation is defined as the removal of electropositive element. Okay, so on removing hydrogen, which is electropositive, that is oxidation. Now, chlorine gas here has formed hydrochloric acid, so which means we added hydrogen to this chlorine gas to form hydrochloric acid. Now, that makes the reaction a reduction because electropositive element has been added. Hydrogen is an example of electropositive element. So this reaction is reduction. So that is the definition of oxidation and then reduction in terms of electron transfer. Now the third definition, okay, the third definition of oxidation and reduction is in terms of electron transfer. Okay, definition of reduction and oxidation in terms of electron transfer. Now, what do we have? Reduction can be defined as the process, okay, of electron gain. Okay, reduction is defined as the process of electron gain. Why oxidation, okay, can be defined as the process, of electron loss. Okay, the loss of electron is oxidation, while the gain of electron is reduction. Now let's take a look at this reaction. Copper 2 ion reacting with hydrogen gas to yield hydrogen ion and copper. All right, now looking at this, copper 2 ion has actually formed copper in that reaction, okay, and hydrogen gas has formed hydrogen ion, as we can see from there. Now, what happened here is that copper 2 ion has gained an electron. It gains an electron. It gains 2 electrons. And on gaining 2 electrons, it becomes copper. Okay? It becomes copper solid. Copper solid is different from copper ion. Now, the gain of electron, we said, is what? Reduction. So meaning that the formation of copper solid from copper 2 ion is reduction because it gains 2 electrons. More so, the hydrogen here, okay, has actually lose 2 electrons, okay, it loses 2 electrons to form hydrogen ion. It forms hydrogen ion in that reaction. So, meaning that the loss of hydrogen, the loss of electron rather, is known as reduction. Loss of electron is known as reduction. Now you will understand this better. Look at sodium that we did the other time. Sodium that has the atomic number 11 and has the electron configuration of 281. It's going to lose one of the outermost electron. Now on losing the outermost electron, it forms sodium ion. Okay, that is the one electron that it actually loses. Now, the loss of electron is oxidation. So meaning this process by which electron is lost, in this case, we can say that the copper 2 ion is reduced to copper, all right, and that hydrogen is oxidized to hydrogen ion, all right. So now that is an illustration. So we have another illustration in the reaction of zinc with bromine gas or liquid to give zinc ion and bromide ion. Now here, it is observed that zinc is giving out 2 electrons. Okay, so loss of electron is oxidation. All right, loss of electron is oxidation. Now here, the bromine liquid is gaining the electrons to become charged, and the gain of electron is known as reduction. So we can say zinc is oxidized to zinc ion. Okay, then bromine is reduced to bromide ion. All right, then finally, we're going to look at the definition of reduction and oxidation with respect in terms of oxidation number. Okay, in terms of oxidation number. So we can define reduction, okay, as the decrease in oxidation number. The decrease in oxidation number, that is reduction, while oxidation is defined as the increase in oxidation number. Okay, so now let's look at the equation we've written the other time. Now we have copper 2 ion reacting with hydrogen gas to yield copper solid. Okay, the oxidation state of copper here is +2. Now it reacted to form copper solid. The oxidation state of an atom or a molecule in a free uncombined state is 0. Now we can see here that the oxidation number from copper 2 ion to 0, it has been reduced. So now from here to here is reduction. Then hydrogen gas here, which has the oxidation state of 0 because it is uncombined. Then here it forms +1 at the product side. Now from 0 to +1, there is an increase. So this is oxidation. So now from copper 2 to copper, we have, that is reduction. From copper to copper, that's reduction. Then hydrogen gas to hydrogen ion, that is oxidation. Okay, so now more so, when we have zinc, okay, reacting, when we have zinc reacting with bromine to give zinc ion and bromide ion. Now the oxidation state for zinc here is 0 and there is +2. Now zinc has been oxidized because there is an increase in oxidation number from 0 to +2. The oxidation state of bromine here is 0 and bromide ion there is -1. Now which means the bromide ion has been reduced from 0 to -1. So we can say that zinc, okay, to zinc ion. So what we have is oxidation because there is an increase in oxidation number. Then from bromine liquid to bromide ion, that is reduction. Okay, that is from 0 to -1. So now those are the definitions of oxidation and reduction in terms of oxidation number. Now we are asked to note that all reactions, okay, are redox. All reaction we have in chemistry are redox reaction, meaning they are reduction and oxidation reaction, with the exception of neutralization, and precipitation reaction. Okay, so precipitation reaction is not a redox reaction. Neutralization reaction is not a redox reaction. Now let's look at the reaction between sodium hydroxide and hydrochloric acid. Sodium hydroxide and hydrochloric acid will produce sodium chloride and water. That's a neutralization reaction. This is a base, this is an acid, while this is salt. Okay, now there is no loss or gain of electron in any way here. Now the charge on sodium is +1, the charge on oxygen is -2, and the charge on hydrogen is also +1. Okay, now let's look at this. Hydrogen here is +1, chlorine is -1. Then at the product side, we have sodium +1, chlorine is -1. Hydrogen here is +1 multiplied by 2, which is +2. Then oxygen here is -2. Now we have +1 +1 -2. So that will be +2 -2. That is 0. Then here +1 -1, that is 0. +1 -1, 0. +1 +2 -2, 0. So meaning 0 plus 0 is 0, equal to 0 plus 0, 0. So 0, there is no gain or loss of electron in this reaction. Why? Because it's a neutralization reaction. So we're going to call it quits here. That is the first part of the call. Then watch out for the next part. But meanwhile, try as much as possible to subscribe to our YouTube channel to get more of this. And at the same time, like us on Facebook. Now, do have a lovely night rest. Bye.